Now, hopefully, we're at the point where we're understanding the situation of where different ratios are positive and negative. So, from the last video, we saw that in any time we've got an angle between 0 and 90, we're going to get a situation where all the ratios of that angle are going to be positive. So, because we're going to positive x, positive y values, then it doesn't matter whether, because our hypotenuse is always going to be positive, we're always going to get in the first quadrant all of our ratios being positive. And then in the second quadrant, because we go a negative x value and a positive y value, sine will be positive, because remember, we're going to have the angle that's going, the angle there, and we're taking this triangle here, so the opposite's going to be a positive and the adjacent's going to be a negative, so we're going to have negative cosine and negative tangent big values because of the negative x value here. So when we take cosine and tangent, we're going to get sine and cosine and tangent being positive, and negative, and only sine being positive. And between 180 and 270, tangent's going to be positive because the sine and cosine will be negative. So for the same reasons. So, and then between 270 and 360, we get cosine being the one that's positive because it's positive x-axis, negative y-axis being involved. So cosine's the only positive one, tan and sine are being negative. Now, we can see that we get back to 360 degrees. We keep in mind that the angles we take every time is back to the x-axis. So either the 0 or 180 or 360. So every time we take the angle, we go looking at the angle back to the x-axis, so we get that related angle in the first quadrant. What would be related to in the first quadrant? So we'll see how we put together finding those angles in a moment. But realize as well that our circle just doesn't stop at 360. It can keep going. We can go up to 450, and then 360 plus 180 would give me 540. And we can keep going around to 720 and do 2 revolutions or 3 revolutions. So that's not a problem to keep going around and doing being in the same spot. So basically the idea that if we go 45 degrees but then go around 360 degrees and get 405 degrees, that would be in exactly the same position. So it doesn't matter whether it's 45 or 405, same position. It'd be 45 degrees in the first quadrant. So it doesn't matter how many times you go around, it'll come back to that same spot every time. So that's what we've got to keep in mind there. We can also realize we can go backwards as well. So 270 could be written as minus 90. 180 could be written as minus 180 because they're in the same positions if we're taking our circle and working in the opposite direction. 90 could also be 450, but it could also be minus 270. If you throw sine, cos, or tan of 90, 450 or minus 270 in, that will give you the same value each time. So keep that in mind. The ASTC, all stations to central, if you want to keep that in mind, or whatever other acronym you want to use. So, the idea here, how do we find the exact value of cosine of 315 degrees? Well, there's a couple of things we've got to look at. Firstly, we've got to consider what quadrant it's in. So 315 degrees is going to be in the fourth quadrant. It's between 270 and 360. And we know that cosine in the fourth quadrant is going to be a negative value. Sorry, going to be a positive value. So if that's the case, the angle that we go back to, so if taking 315 degrees goes all the way around there, but remember we want to get this related angle. What's the angle back to the x-axis? And that'll be 45. So cosine of 360 minus 45 is the same as cosine of 45. And from our tables from before, we know cos of 45 is 1 on root 2. Now you could check that answer. Throw it in your calculator. Cos of 45 and cos of 315 will give you the same answer in the calculator. So that's all okay. That's not a problem to check it. But remember, we're looking for the exact value, so we need that exact value like we had in our tables. Sine of 240, well, 240 is between 180 and 270, so that makes it in the third quadrant. So remember, we're looking for the related angle now. Sine, third quadrant, our answer is going to be negative. So what's the angle that goes to 240, but what's the angle we go back to the x-axis? And that would be 60 degrees there. So that's where we get the 180 plus 60 is 240, so we can match that up. But then we need that related angle. So we're going to take sine of that angle, but because it's 180 plus the angle and we're in the third quadrant, we're going to have negative. So sine of 60 is root 3 on 2, and we've got the negative root 3 on 2. Tan of 210, well, where is tan of 210 minus 210 degrees? Sorry. That's going to go back 90, go back 180, and go another 30 degrees there, and we're at minus 210. So it's in the second quadrant between minus 180 and minus 270. So we're back in the second quadrant, and tan in the second quadrant gives us a negative answer. So we're going to get that. But again, what's the angle that we go back to the x-axis? We get that 30 degrees. So tan of 1 minus 180 minus 30 is the same as tan of 180 minus 30. So it doesn't matter which one. It's still going to give us minus tan of 30. There's our related angle. And tan of 30 is 1 on root 3. So minus 1 on root 3 all up. 150 degrees is in the second quadrant. So sine in the second quadrant is a positive answer. So that's where we've got the positive answer at the end. Again, what angle is it back to the x-axis? Well, a related angle gives us 30 degrees. So sine of 30 is a half. So that's how we start to look. We're looking for those two things. What quadrant am I in? And then so that gives me the sine. And then what's the related angle? This time cosine of 150, which is in the second quadrant, is going to give us a negative answer. And it's 180, back to 180 would be 30 degrees. So back to that x-axis gives us cosine of 30, which is root 3 on 2. So minus root 3 on 2. Sine of 300, sine in the fourth quadrant is negative. So that's where our negative comes from. And 300 is 60 degrees away from 360 on the x-axis. So that's where we get a related angle of 60 degrees. And sine of 60 is root 3 on 2. So minus root 3 on 2 is our answer for that. Tan of minus 135. Again, where's minus 135? We go back 90. We go back another 45 degrees to give us minus 135 degrees. So again, it's 45 degrees to the x-axis. We keep going to the x-axis, how far it is. So that's where we get our related angle. Tan in the third quadrant is going to be a positive answer. So it just becomes tan of 45. We're looking at that related angle. Tan of 45 is 1 from our table. Sine of 120, we're in the second quadrant. So that means it's going to be a positive answer. And it's 60 degrees as a related angle. Back to the x-axis, so root 3 on 2. Tan of 225. We're in the third quadrant now. And tan is positive in the third quadrant. 225 to 180 would be 45 degrees. So tan of 45 gives us the 1. Cosine of minus 210. Well, we said minus 210 before is in the second quadrant. So cosine in the second quadrant is going to give us a negative answer. And our related angle is 30 because it's 30 degrees to minus 180. So cosine of 30 degrees is root 3 on 2. Tan of 210. Tan 210 is in the third quadrant, so our answer is positive. And then our related angle is going to be 30 degrees because it's 30 degrees back to 180 degrees. So it gives us 1 on root 3. Sine of 240. 240 is in the third quadrant. So, and sine in the third quadrant is negative. What's our related angle? We relate it back to the 60 degree angle because it's 60 degrees back to 180 degrees. So it gives us sine of 60, which is root 3 on 2. So hopefully we're getting this pattern of where these are existing. Cos of minus 45, well, minus 45 is just back in the fourth quadrant. We're going back to minus 45 there. So we're starting back 0, that would be minus 90, so halfway through, it's 45 degrees. Again, our related angle is 45. So it's the same as saying 0 minus 45, well, it's 360 minus 45 if we're dealing with our 0 to 360. Because fourth quadrant is positive, cos of 45 is 1 on root 2. Tan, second quadrant, is negative. And then 150 is 30 degrees away from 180. So we get tan of 30 as our related angle. So 1 on root 3. 405 this time. Well, we talked about this one before. So the idea, if we go through one revolution and then keep going. So that's 360. We keep going to 405. That's 45 degrees past 360. So that means our related angle is going to be 45 because it's in the same position. Sine of 405 and sine of 45 goes in the same direction. So it doesn't matter whether we take sine of 405 or sine of 45, we're going to get that same angle each time. Same as sine of 90 and sine of 450 would be exactly the same. It's going in the same direction. So that's where we say 405 minus 360 gives us the sine of 45, which is 1 on root 2. 690, well, again, where is 690? We go around a 360 degree circle and we're going again. So we would be round to the fourth quadrant because it's almost 2 complete revolutions. 2 complete revolutions would be 720. So we're 30 degrees off that. So that's where we get our 30 degrees as our related angle because it's 30 degrees back to the x-axis. 690 is 1 revolution and then 330 degrees around again. That's where we get cos of 360s in the same 330s in the same position as cos of 390. Cosine, fourth quadrant, positive, and our related angle is 30 degrees. So that's where we get the root 3 on 2. So they're the things two things we got to look for. Where is what quadrant are we in? So that's going to give us our angle that's going to give us our quadrant and our sine of our ratio. And then what's our related angle? What's that angle back to the x-axis, whether it's on the positive x-axis over this side or the negative x-axis. But what's the angle back to that so we can get our related angle, and we either have a positive or negative ratio of our related angle there.